All right. So now we're going to talk about the second part of section 11.1. Again, we're talking about the basic equations. And what we're going to talk about today is we're going to talk about angle of inclination and distance from a point to a line. So I just have three quick examples to run through with you on this. I'll try and make them brief. These are formulas you have to memorize and then know how to use them. The first one, angle of inclination, is very, very easy. So if we have a line, let's say something like this. So there's our graph. Here's your x-axis. Here's your y-axis. The angle of inclination is the angle measured from the positive x-axis in this direction to the line. That's the angle of inclination. And it turns out that that angle of inclination, the tangent, of that angle of inclination is equal to the slope of the line. So basically what's going on is if we draw a vertical and a horizontal here, 90-degree angle, we have a right triangle. Okay, here's your rise, here's your run. If we pretended that theta was in here, then the tangent of theta is equal to opposite over adjacent, rise over run. So tangent of theta is equal to the slope. Now, of course, theta is not really there. Theta is actually measured out here. But we dealt with this in trigonometry when we were dealing with standard position. And we know that we can treat theta as if it was inside of this triangle over here as long as we make adjustments for what quadrant we're in. And that gets taken care of by our slope. The slope will take into account whether this thing is sloping downward or sloping upward, whether it's a negative slope or a positive slope, which takes care of that adjustment for us. So that's the idea of where this comes from conceptually. So how do we actually use this? So let's take a graph. And let's say we have the line y is equal to 1/3 x minus 2. So we know it has a y-intercept of -2, and it has a slope of up 1 and over 3 to the right. Up 1 over 3. I'm just going to draw this a few times, then it's easier for me to sketch my line in, since I can only drag it in one direction. Here's our line. What we want to do is we want to measure the angle of inclination measured from the positive x-axis, going counterclockwise. So there's our angle theta. We know our slope here is 1/3, and so we know that tangent of theta is equal to 1/3, which therefore makes theta equal to inverse tangent of 1/3. This is now going to go into our calculator. This can be done in either degrees or radians. My preference, just do it in degrees unless they ask you otherwise. This is in degrees. You certainly don't have to do it both ways. Inverse tangent of 1 divided by 3. Just make sure if you're going to do it in degrees, make sure your answer has a degrees on it. If you're doing it in radians, make sure your answer does not have a degree mark on it. You don't have to do it in terms of pi. It can just be as a decimal. But we're going to do degrees typically. This is about 18.4 degrees. And notice that that looks like a reasonable value for that angle. Okay? On the other picture, the first picture I drew, we would expect this angle to be something, maybe in the 130 degree neighborhood, because clearly that's an obtuse angle, so it's got to be bigger than 90. And that will all be taken care of because of the positive or negative value on your slope. Okay, so that's it for angle of inclination. It's really just that easy. The next thing we need to do is we need to talk about the distance from a point to a line. So if I have a line so our red line, and I have a point that's not on that line, and I want to find the distance, which means the perpendicular distance from the point to the line. That's typically a very complicated process, because what we would have to do is we would know the equation of the line, so we would know the slope. We would know this point, so we know its x and y coordinates. We would have to start by finding from the slope of the line the slope of the perpendicular distance. Because they are perpendicular, they will be opposite reciprocals. So we can take the opposite reciprocal of this slope, and we can then find the slope of this little line right here. We would then need to solve a system of we would then need to find the equation of this line by doing point slope form or slope intercept form. We would then need to take the equations of our two lines and solve a system of equations to find the point where those two intersect. And then once we've done all that, then we would then have to do the distance formula from here to here. Okay? So you need the slope of this one. You need the slope of this one. You would need the equation of this one. You would need the solution to the system of equations. And then you would need the distance formula. There would be 5 separate steps in doing this problem. You could certainly do it, but it's a messy way to go. There's actually a nice formula, actually 2 different versions of the formula, that will take care of this automatically for us. And that's what we're going to talk about now. So, distance from a point to a line. So the distance from a point to a line, let's say we have the line y equals 2x minus 3, and we have a point -1, 4. I'm going to call the point x0, y0. Okay, that's our starting point. That's where we're going to start measuring the distance from. We're going to measure that to the line, which clearly has an m, a slope of 2, and a y-intercept value of -3. So there's my slope, there's my y-intercept. With m be x0, y0, we can find the slope of the line using the following equation. Notice this is slope-intercept form. After I show you the slope-intercept version, I will show you that there's also a standard form version of this equation as well. Now, on the homework, they will ask you to, part A will ask you to do it using slope-intercept, part B will ask you to do it using standard form. I do not need you guys or want you guys to do both. So what my recommendation is, decide which form you want to work with, and typically I take my cue from the way it's given to me. But decide which form you want to work with, make sure the equation of the line is in that form, and then just do that one version. You don't have to do it twice. Okay? I don't have any need for that. If you show me that you know how to do it once, one way, that's fine. The truth is that you could always take slope-intercept and change it into standard form and then do the standard form version. Or you could take standard form and change it into slope-intercept form and do the slope-intercept form version. So it really doesn't matter. It's not like you absolutely positively have to know both. If you have one that you prefer, then know that one, and then just make sure that you change the form of the line into the proper form before you plug it in. All right. Distance is equal to, this is a big fraction. On the top of the fraction is a big absolute value, because distance has to be positive. The bottom of the fraction is going to be a square root. We know the square root, being the principal square root symbol, has to give us a positive answer. So we need to make sure that the numerator also gives us a positive answer so that our distance is positive. So that's what the absolute value is there for, just to guarantee our distance is positive. So the formula is the slope times the x-coordinate of the point plus the y-intercept minus the y-coordinate of the point over the square root of 1 plus the slope squared. This is the equation that you have to know. mx0 plus b minus y0 in absolute values divided by the square root of 1 plus m squared. This will do all those 5 steps for us. And so plugging our numbers in, our slope is 2, our x0 is -1, plus our b, which is -3, minus y0 is 4 divided by 1 plus the slope squared. So the top gives us negative 2 plus negative 3 minus 4. So negative 2 plus negative 3 is negative 5. Minus 4 gives us the absolute value of negative 9 divided by the square root of 1 plus 4 is 5. This then becomes positive 9 over the square root of 5, which means that our distance, when we rationalize it, is 9 rad 5 over 5. That is the perpendicular distance from this point to this line without having to go through 5 steps to do it. It's a very nice equation, but you have to have it memorized. All right. The last example I want to do for you today is I want to do the exact same thing, but now I want to do it in standard form. So I'm going to start with the same equation so we can see it gives us the same answer. If I put this into standard form, number one, I'm not allowed fractions. There aren't any. Number two, I have to move everything to the left side. So negative 2x plus y plus 3 equals 0. Remember that a is supposed to be positive. We talked about that in the last video. So that's really 2x minus y minus 3 equals 0. So does everybody see, hopefully, that this is the same equation as this, just in standard form? So I'm going to start on a new screen with our equation 2x minus y minus 3 equals 0. We're still going to use the same point, which is going to be negative 1 comma 4. So here's my x0, here's my y0. Remember, standard form is ax plus by plus c equals 0. So my a is equal to 2, my b is equal to negative 1, my c is equal to negative 3. And the standard form version of our distance from a point to a line equation is distance is equal to, again, the basic structure is the same. You have a square root on the bottom, you have an absolute value on the top. This is going to be a times x0 plus b times y0 plus c. Notice no minuses in there. The square root is a squared plus b squared. So again, knowing these things, a, b, c, x0, y0, we can find our distance automatically. Absolute value of a times x0 plus b times y0 plus c over the square root of a squared plus b squared. Don't forget to use parentheses when you plug in. That's the absolute value of negative 2 plus negative 4 is negative 6 plus negative 3 is negative 9 again, divided by the square root of 4 plus 1 is 5. So this becomes 9 over square root of 5. So notice this gives us the same answer. And again, you can ignore on the assignment the instruction to do each problem both ways, in part A and part B. You only have to do it one way. My preference, if they give it to me in slope-intercept form, I use the slope-intercept version. If they give it to me in standard form, I use the standard form version. That's how I prefer to do it. If you just really want to memorize one formula, that's fine. Just make sure that you rearrange the equation of the line into the right form to match that formula. And that is perfectly acceptable with me. All right, that's it.